Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullah wa barakatuh. Dear students, BS Physics, Semester 1, Mechanics 1, Course Code, Physics 1103, Lecture number 13, Chapter number 4, Two-Dimensional Motion. This lecture is named Uniform Circular Motion. Dear students, I am talking to you, Rashmat Ali, Assistant Professor of Physics, Khaja Fareed Government Postgraduate College, Rimia Khan. The material of this lecture I have taken from the course book, The Outlines of the BS Physics, as recommended from the university, is the Physics for Scientists and Engineers by Survey Javed. Another book, Fundamentals of Physics by Gerald Walker. The main contents of this lecture are uniform circular motion, centripetal acceleration, period for the circular motion, and types of the acceleration in circular motion. First of all, the circular motion. Take the view of a circular motion. We can see easily a circle dotted by blue line. A car is moving. The red line shows the tangential velocity. O is the center and R is its radius. When a body moves in a circular path, its velocity will change either by magnitude or by direction. If the magnitude of velocity is constant, that is, speed of a body is constant, then velocity will be changed even then by changing its direction. Now we'll see the definition of circular motion, then uniform circular motion. Motion of a body in a circle or circular path is called circular motion. But when a body moves with uniform speed in a circle, it is called uniform circular motion. In a circle, even the speed of the body is constant, but its velocity will be variable due to change in direction. If velocity changes, then acceleration will be produced. We know acceleration is the time rate of change of velocity. So acceleration will be produced either change in magnitude, means speed, or change in direction, or both magnitude and direction. In uniform circular motion, the speed is constant but velocity is changing. The average acceleration is given by A is equal to A bar shows the average acceleration delta V over delta T. V is the velocity, boldface is written here. The velocity vector is always tangent to the circle. Acceleration is along delta V, that is perpendicular to the radius of circular path. So acceleration is along the radius directed towards the center of the circle. Now the centripetal acceleration, if we see the image here, circular path, velocity is tangent to the circle at each and every point. The force will be directed toward the center of the circle. As force and acceleration are directly related, where force is present, acceleration will also be present. In the second diagram, velocity and acceleration are projected here. The acceleration is radial acceleration. Velocity is always tangent to the circle, and the acceleration is always directed toward the center of the circle. Centripetal acceleration, the acceleration of a body moving with uniform circular motion, always directed toward the center of the circle, is called centripetal acceleration. Here word centripetal means center seeking, directed towards the center. The mathematical form of this centripetal acceleration is AC. C is subscription for centripetal V square over R. V is speed here, R is the radius. Now, derivation of this relation. This article is considered as a descriptive article, as a long question according paper point of view. Consider a body is moving along a circle from point A to B. Vi is velocity and Ri is its radius at point A. Vf is the velocity and Rf is the radius at point B. This is shown a small cut piece of a circle motion from A to B. Dotted line is a part of circle. Ri is its radius. As radius is a vector directed always outward from the center of circle. R is the bold phase. Ri is the initial position or radius. Rf is the final position or radius. Angle theta, delta theta is made in between the two radius vectors. Similarly, at point A, velocity is Vi, initial velocity, that is tangent to the point A. At point B, velocity is again Vf and tangent to the point B. The displacement will be shortest distance from A to B, represented by delta R, and the distance will be from A to B, arc length, curved path. If displacement is small, delta r will be small and delta theta will be small. The velocity vectors are joined here, Vf and Vi. Delta V is their resultant vector and makes an angle delta theta. Since speed is constant, so magnitude of velocity is constant and direction is changing, so acceleration will be produced. We can write the acceleration as A equal to average acceleration Vf minus Vi over Tf minus Ti, in short delta V over delta T. Consider the two triangles. In both the cases, delta theta is same because the magnitude of radius and magnitude of Vi and Vf is same. So both are the same triangle. In this case, if the triangles are same, then the change in velocity over velocity, the change in radius over radius in the magnitude of these vectors will be equal to the delta theta. So these vectors will be same. Finding the value for the delta V and substituting the above equation in delta V. Here, when we use the boldface, no need of arrowhead above, and when we use the simple characters, we put an arrow above it. So putting the value of delta V, we get a value V over R, magnitude of delta R over delta T. For a short interval of time, when point A approaches to B, we can see here, means delta T is small, delta T approaches to 0, then delta R over delta T approaches to speed V. The magnitude of the acceleration is centripetal acceleration, AC equal to V square over R. This is centripetal acceleration. We can put delta R over delta T by V, so this becomes V square over R. Now, if a body moves in a circular path, it takes time. The time required for one complete revolution, rotation, circle, is called period of circular motion. If the time interval is t capital, the body moves a distance 2 pi r, which is the circumference of the circle. Let v be the speed, then period of circular motion is given by t equal to 2 pi r over v. This has been driven from simple formula v is equal to s over t. Here s will be 2 pi r, replacing, exchanging t by v and v by t. So this will be the period of rotation or circular motion. When a body moves in a circular path, at least one force is must present there. The other force is produced by its reaction force. The force which compels the body to move in a circular path is a centripetal force, means center-seeking force. And the other force will be that the reaction is centrifugal force that tends the body to move out of the circle. A short question may be asked in paper. Differentiate between centripetal and centrifugal force. Centripetal force, the force acting on the body to move it towards the center of circle, is called centripetal force, and the force acting on the body to move it away from the circle, center of circle, is called centrifugal force. Centripetal force is a action force, but the centrifugal force is a reaction force. Centripetal force can be written as Fc equal to mv square over r, whereas Fg is equal to minus Fc. G is written for centrifugal. Now, when a body moves in a circular path, it has two types of acceleration. One is AR, means radius acceleration, and other is AT, means tangential acceleration. We can observe from this figure two circles are shown of about same radius, and another circle are shown with greater radius. A colored path, zigzag path, is shown here. A body starts its motion from certain point, but at point A, the acceleration has the two components. One is the tangential component, that is along tangent to the path to the circle, and other is radial component, that is directed towards the center of the circle. The both have the resultant A acceleration. Similarly, at point B, the tangential acceleration and the radial acceleration both are shown. Also at point C, radial and tangential acceleration are shown here. Radial acceleration has a value of minus v square over r into r cap, r unit vector, is a radial acceleration. Negative sign here shows that the radial acceleration is directed towards the center of circle, whereas radius vector is away from the center of circle, means by direction radius vector and acceleration vector are opposite to each other. Whereas tangential velocity, tangential acceleration is equal to dv over dt into theta cap, that is the direction of theta. Its magnitude is shown here. A magnitude is equal to square root AR square plus AT square. A small differentiate between the tangential and radial acceleration. Radial acceleration, the acceleration of a body moving in a circle along the radius of circle, is called radial acceleration. This component arises due to the change in direction of velocity. We can also call it a centripetal acceleration. AC equal to AR minus VC over V square over R into R cap. Whereas tangential acceleration, the acceleration of a body moving in a circle along the tangent to the circle is called tangential acceleration. The tangential component causes the change in the speed of body, so AT is equal to dV over dt. Theta is the angle. The lecture comes to end. So thanks for listening with patience. Allah bless you all.